is to assume the internal force is intention. So we have a equation. So we can find that it's how much? Understand? One six. Because the loading on the body part is simple, so we analyze the body part, assume its intention, and always assume the rod is intention. So it means when at this section the rod is intention because it's a minus. For this section the rod is intention because it is positive. For this section it is also intention because the internal force, the normal force is positive. Understand? Is there any question? Copy it. Don't make any sense. It's just an example. Okay. Is the example last lecture I told you? Let's continue. Okay. Okay, let me. Last lecture we learned how to find the stress on the cross section for rod. For rod, it's the formula. It's the formula to find the stress, normal stress happened on the cross section for an excellent loading rod. It's all convenient. Okay. Understand?
Yes.
Perfect.
When N2 equal to N2 equal to
Why not ask me before my convenient?
yeah.
You know
N2 equal to
into 2 equal to N to
section 2 equal to 50. Oh.
you missed it. Last lecture, we learned how to find the normal stress absolute loaded member. We got the formula. Is the formula to find the stress on the cross section of for absolute loading rod. Is the stress on the cross section for the rod is the formula. Is the example. That's last lecture we just find the internal force. We didn't finish it.
Yes.
We just finished. We just find the internal force. How to find the stress in the rock, in the rock. Because in section AB, the normal force is treble. For section BC, segment BC, the internal force is 30. In this segment, it's 22. Yes, sir? So we can imagine, we can think of it. Let's think of it. Which segment is more danger for the rock? Which segment is more danger? For the three sections, the mid segment must be more danger because the internal force is high, so it's danger. So we have to find the stress happened in the section. How much is it? It's MVC divided by area, the area of the cross section, we can get 85.7 m pascal. If a problem asks you to find the stress, it always means asking you to find the largest stress. It means for the problem, the stress in segment AP or the stress in segment CD, we didn't find it because we don't care it. We just find the largest one. So we just find the stress happened in BC. In BC. Understand?
Yes, sir.
Because BC is the dangerous segment. It's the normal stress. Let's introduce average shear stress. Shear stress. Here is an example. Shear is a stress component that acts parallel to the cross section in the figure. We assume the shear stress is uniform on the shear area. On the area, shear stress is distributed over each section area that develops this shear force. For this one, AC, I drew the flipped diagram of the top rock. AC. Look at data. It's F. Yes. F is attack, exerted attack. B, the block will exert a force on the rock. Yes, on the rock. Where exert the forces on the rock. So let's imagine to calculate calculate. Calculate. Let's calculate. On the surface, there is tau equal V over A, because the resultant of this stress must be V. Yes or no?
Yes, sir.
Yes, sir. So the shear stress having on the surface is V over A. We assume the shear stress is uniform on the section, because we can't get the precious answer on the cross section. So we just find the average result. Understand?
Yes.
Okay. Is the shear stress.
No. Shear stress.
Shear stress.
Yeah.
Is shear stress. Shear stress is parallel to the section. Is parallel to the section. Normal force is perpendicular to the section. They're different. Here is an example. Okay, let's explain it. Determine the average shear stress in the 20 millimeter diameter pin at A and the 30 millimeter diameter pin at B. Then suppose the B in the figure. At the point A, here is a pin. At the point B is also a pin. Look at the figure. The structure says in details information is in the figure. It's a pin A, it's a pin A. At first, we have to find the reaction. I tell you how to find the reaction. Maybe if you get at first, we find the reactions at A and B. It is static. Yes or no?
Yes.
I told you how to find the reactions at first. We do the frequent diagram because it's plane supporter. Because it's a plane supporter, so there are two components, two forces, AY and AX. For this, because it's a loop, so there is a force along the loop is aware from the body. Understand? I introduced it at the beginning. Yes, no?
Yes.
So, at first, we have to find the reactions. How to find it? Yeah. 21.36 kilonewton. How to find that? At first, sigma MA equals 0. Sigma MA equals 0. It's FB times 4 over 5. Do you know the meaning? You don't know? Huh? It's A X is A1 is 30 is FB is resolve FB into its two perpendicular components. This component is FB times is 3/5. This component is 4/5 FB. Understand? Understand? Is how to resolve a force into its component. File 3 theta cosine theta equal sin theta. Understand? So, summation, the moment about the point A must be 0 because the rod is balanced. So, FB times 4/5, it means the force. It means the force. It's a component of FB. The distance is the line of action of the force. The perpendicular distance from the point to the line of the force is the length is 4 plus 2, so it's 6 meters. The rotation is anti-clockwise. Yes, anti-clockwise is positive. The other, for this force, for this component, because it is pass through point A, the distance is 0. So, in the equation, there is no the force. There is no the force. Because the moment of the force about point A is 0. Understand? Here is the applied load. The magnitude is 30. The distance is 2. The rotation is clockwise. Clockwise is negative. It's not 30 times 2. So it's equal to 0. From the equation, we can find FB is 12.5. It's statics. We can get the other equation. Equilibrium equation. It means it's FB. It means it's FB times 3/5 because the component is in horizontal. The meaning of this sigma fx is the summation of all the horizontal force is 0. So it's AX minus it's positive, it's negative. So we find the AX is 7.5. Then last balance equation is equal to y equals 0. Find the if AY positive, negative, yes or no? Because it pointed downward. Because it's downward, it's upward. This one is upward. So AY plus FB times 4/5 minus 30 is 0. So I can find AY is 20 kilonewton. Understand? It's simple because at the beginning I introduced the simple statics. If you understand this problem, how to find the reactions, you can understand the mechanics of materials. It doesn't matter for you. After you, so we can find FA because because AX and AY are the two components of A. So we can find FA square root of AX square plus AY square. We will find if A is 21.36 kilonewton. Understand?
Yes.
So from the Freiburg diagram of pin A, we can find that VA. How much is VA? VA is half FA. Yes, sir. Because each way, so VA is half FA. So half FA is 10.68 kilonewton. You didn't copy that because you have the PPT. Is VA. VP is FB. VP FB. Look at the structure, the details at pin B. Look at the details at pin B. Pin B is VP. There is just one shell cross section. There are two shell sections. The right section, the left section. Yes, sir. For this one, they just got one section. So VP is FB. So from the formula we can find tau A average is VA over AA. Tau B average is VB over AB. The area of the shell section is the area of theta. The area of theta d square. It's not half d square. Because we know the dimension of the radius, the diameter of that. 你看，at pin A, diameter is 20, so radius is 10. Yes or not? So is the diameter. Yes or not? The area of theta is this one. Is pi 4 d square. Pi over 4 d square. So we can find the result. In the same way, we find top B is 17.7. Any question here? Maybe the problem is a little difficult. I show you a simple. Okay. Here is an example. Suppose Suppose the force is 100 Newton. That's right. The dimension is 10 millimeter. The head is 5 millimeter. Let's find the stress, the shear stress having in the top block. Okay? At first, we have to find the shear force. Yes, we have to find the shear force. When you want to find it, because shear force is internal force. So we have first get the flip diagram. Remove all the surroundings. Remove all the surroundings. Yes, This part is the first. This part is the first. Yes, we can, because they are equal. Semi-K, because it is semi-K. So 50 Newton is 50 Newton. Yes, because the block, the loading is semi-K. So the force and the force are equal. So is 50. After we find the reactions, we have to find the shear force. The shear force is 5. Is the name will and on the that is the weight is a shear force is a 10 in the 5, okay? On the section is also a weight. It's not. The weight is a 50, is also 50. We know tau equal V over A. It's not. So it's a 50 Newton over the diagram is 10. Would explain it in meter because it's a millimeter. It's not changing the to meter times 12. So it's how much? It's 1 Pascal. It is 1 M Pascal. Understand? Is the shear force, is the shear stress happened on the section? Is average, it's average shear stress on the section. V is the shear force, V is the shear force, A is the area. Understand? So, up to now, I introduced what is normal stress, what is shear stress. I show you long practice. If the chalk is intention, when it break, the cut must be the cross section. Yes or no? Yeah. Because when the rod is in axial loading, the biggest normal stress is happened on the cross section. But when I torque it, the cut must be an oblique surface. Must be oblique surface. Therefore, the angle between the cut and the cross section must be 45. And torque it is an oblique cut. Because for chalk, when the normal stress come to maximum value, it will be break. when a rod is intrusion, the largest normal stress happened on the oblique surface. When it is intention, the largest normal stress is happened on the cross section. So when it's intention, the cut is cross section. When it's intuition, the cut is oblique. Understand?
Yes.
In the future, if you are an engineer, you will have to check the projection where there is a correct. You have to, before you check it, you have to think where is the correct. That's not because a projection, a bridge is so huge you can't check it a place, one place, check it all the places. Yes or not? You just check the danger place. So before you check the bridge, you have to think how to check it. Understand? So here is the stress on oblique surface for any solid member. For any, because if it's a steel rod, when you touch it, the cut must be an oblique cut, different from chalk. If the rod is made of steel, the cut will be different. Yeah.
That's why.
If it's a steel rod, because the steel rod, when the steel rod is break, it's because of shear stress. When chalk is break, it's broken. It's because of normal stress. They are different.
There is no shares.
Yeah. Chalk is because of normal stress. Steel is because of shear stress. Different materials, when it is broken, the reason are different. Understand? Some is because of shear stress. Some is because of normal stress.
So, what about our body?
I don't know, because it is not a building material. Yes, no.
Yes. So we have shares.
No.
Also.
How to judge how to judge why the material is broken? It's a bad experiment. It's a bad experiment. But in engineering practice, we can divide all the materials into two parts. One is because of shear force, the other one is because of normal stress. Understand?
We can use experiment.
Stress. So we have to find the stress. Oh, it's time for break. Okay, let's have a break. Okay. Yes. In the previous lecture, I introduced how to find the shear stress. How to find the shear stress.
Shares stress.
Shear stress.
T. Lovely. What is this one? T or tau?
How?
Why? Does this look like T?
No. We call it tau.
Tau is English?
Not here.
Is silent?
we call it Tao.
How?
Not
This is not T.
yeah,
How?
Spanish.
Spanish.
normal stress is sigma is NA is raised in. Yes, I introduced the two formulas. Okay. Bearing stress. What is the bearing stress? Bearing stress for the board. For the board. For the board. When the force acting on it, and in practice, if you want to connect the two plates, it's not. We have to bolt each other. Suppose it's effort. It's also effort. The Friedman diagram of the bolt is like this. It's like this. It's not. If the force is too large, the sigma will deform. The sigma will deform. The force compress on the surface. If the deformation is too large, the connection can work normally. So we have to calculate the bearing stress. The bearing stress. But the bearing stress distributed on the surface is very complicated. Is very complicated. So we just find it in a simple way. We assume the bearing stress on the surface is uniform, and the plane is this plane, and it's a cylindric. It's a diameter. You know the diameter. The diameter. Remove this equation. The shadow plane. The shadow plane is the bearing force. We call it the sigma BS, bearing force. It means if the connection must be safety, one is working. One of the loading acting on the connection, it must be safety. So there are two conditions must be satisfied. One is the shear force must smaller than the renewable stress. It means if the stress is much more than renewable stress, the materials will be break. Will break. So the shear stress the shear stress the shear stress must be smaller than the aluminum stress. The bearing stress must be smaller than the aluminum stress. What is the aluminum stress? I will introduce it. It means when the stress is much more than aluminum stress, the body will be broken. Aluminum stress. Aluminum stress. Okay. After a while, I will introduce it. At first, let stress on oblique surface. We know how to find the stress on the cross section. Sigma is A/A. But how to find the normal stress on the oblique surface? We don't know. It's not. So the normal force is also P. Suppose the rod is in tension on an oblique surface. The normal stress is also P. So when you want to find the normal stress on the oblique surface, is P. Sigma is P over A. Yes or no? For an oblique surface is also P. Is the area of the cross section. So the area of the oblique is the area of this surface is A theta. It's AO is A theta cosine theta. The angle is theta. No. It's not the same theta. Theta is this. Is theta. Is theta. So this angle is theta. Yes or not? Understand? So AO is A theta, cosine theta. The normal stress, sigma theta is P over A theta. So is equal P A O cosine theta. No. P A theta A O cosine theta. So equal sigma cosine theta. 应该是这样的。So sigma is AO cosine theta. theta equal P over the area is AO cosine theta. This one is the sigma. Is this sigma? Is this one? And then highest cosine theta. Yeah. The direction. Sigma is x. Suppose it's x direction. Yes or no? It's x direction. So is sigma theta and sigma x cosine theta because it's theta. It's tau equal sigma x sin theta. Right. Resolve it into two directions. So sigma is tau. Sigma equal sigma x cosine theta. Sigma x equal P A in A0 cosine theta. So cosine theta. So it's sigma cosine theta square. By the same way, we can find the tau is sigma sin it's half sigma sin 2 theta. Is this? Because 2 sin theta cosine theta is sin 2 theta. Do you know the formula? Sin 2 theta is 2 sin theta cosine theta.
Yeah.
So we can find the formula. How to find the stress having on the oblique surface.
So how have you found the formulas?
What?
Can you just explain how you found those formulas there?
Yeah,
Explain.
explain the formula.
Yes.
Is the stress having on the cross section normal stress? Is the stress on the oblique surface normal stress? The relation is this. If you know the normal stress on the cross section, we can find the normal stress on the oblique surface. If you know the normal stress on the cross section, we can find the shear stress on the oblique surface. Yeah.
Here is
No. You told me what?
this cos means cos is here.
Yeah.
But this cos also here.
Yeah.
Cos-
So is
cos-
square.
So how to write cos equal to cos square? Yeah, sigma equal to P by A.
No, sigma x is P over the area. The area over the area.
Yeah.
The area is AO over cosine theta. This?
That's mean
Yeah.
A equal to
Yeah.
this causes this and A equal to this.
Yeah.
Because that's mean if you give some volt, the equal to this.
Some volt?
Yeah, volt. A equal to A0 divided cos like this one. So I didn't understand.
It's complicated. You just remember.
No.
Not easy.
Let's keep note.
You didn't know it because it's I have to spend a lot of time to explain it. You don't know. So if you don't know the result, it's enough. Okay? At last, I want to introduce the allure stress. It's an important conception. Design components with safety measure using factor of safety. Allure stress. Allure stress. What is allure stress? Suppose if the rock is chalk, when the loading is 10 Newton, it will be broken. Then you need the pin working at 10 Newton. Then you can't, because we are afraid it will be broken. Yes or no? It means in experiment, when the loading is 100 kilonewton, the pin will be broken. In practice, the loading must be more than 100 kilonewton. So we have to set a factor of safety. Factor of safety. It means is a F failure. F failure. How to get the F failure? We get it from experiment. It means when the loading is 10 Newton, the chalk will be broken. In practice, the loading must be smaller than 10 Newton. Yes or no? According to the experience, we have to get a factor of safety. Suppose we get a factor of safety is 2. So the allowable loading 10 Newton divided by 2 is 5 Newton. It means by experiment, when the loading is 10 Newton, it will be broken. In engineer practice, we just allow the loading must be smaller than 5 Newton. In this way, the chalk will be safety. Answer that? So, failure loading divided by allowable loading is a factor of safety. Factor of safety. So, is a factor of safety is also can be gotten by sigma failure over allowable stress. So when you design a member, the stress must be less than the allowable stress. Must be less than the allowable stress. How to determine factor of safety is an important problem. Yes, is an important problem. It determined by experience. Experience. Yeah, is an important problem. How to determine the factor of safety is determined by a lot of engineering, a lot of professor. Maybe we have to get a lot of meeting to determine it. In practice, when the factor of safety is determined, everyone can do change it. It is determined by code. It is determined by code. Is factor of safety. So after we introduced allowable stress, we can introduce how to design a simple connection. How to design a simple connection. And for these two blocks, to plane connected by the pin. Yes or not? It's the pin. There are several failure models for bulk or the pin operator. Yes or not? This one, the stress adjustment in the pin may be more than allowable stress. It means when the stress is more than the allowable stress, it means the fault will be broken like this. Yes, sir. The blade may be cut, may be broken on the cross section. Yes or no? Let's focus on shell failure of boat. Shell failure on board, it means the shell stress is more than shell allowable stress. Bearing failure of a boat, it means the bearing stress more than the bearing allowable stress. So there is several failure modes in a boat. This example is difficult. Let's pay attention to this one. Design the largest node T that can be applied on the box of the left giant shown in the figure. In the figure, the board has a diameter of 10 mm and a allowable stress is 80. Yeah. Each plate has an allowable tensile stress of 50. MPa. And allowable bearing stress of 80 MPa. And allowable shear stress of 30 MPa. Determine the largest load P. It means when P is more than the largest value, the structure will be broken. That's all. How to determine it? So, because allowable stress when the plate is in tension is N over A. Yes or not? Is the flip on the diagram of the plate? It's P. Yes or not? It's P. Is the flip of the diagram of the plate? With the bottom plate. Yes or not? Flip of the diagram. So, if the plate will be broken, where is the dangerous cross section? Is in the S? No, because the cross section, the area of the section, cross section is more than the cross section of this. Yes or not? So, it is the most dangerous cross section, because the area of the cross section in this location is small. Is small cottage. Is the cross section? Yes or not? Is the cross. So the area is small. So is a dangerous location. So it's a dangerous location. Second, allowable stress is NOA. Is the allowable stress is 50 Newton per square meter, or P over the cross section. So we can find P is 30 kilonewton. It means when P is more than 30 kilonewton, the stress, the normal stress on the cross section must be more than 50 MPa. It's not. It means if P is more than 30, the plate will be broken. So, from this result, it tells us the loading must be less than 30. If the failure is because of the bolt, for the bolt is the bearing allowable stress. And is also N over A.
N means number two, yeah.
Because V is, we know, because is the bolt. Yes or not?
Yes.
Is V is a V. Listen up, because V is P is N in the problem. Eh? The border. Look at the figure. The border is here. Listen up. So it's a P. It's also P. Listen up. So let's find the V. We can find the V is P. Listen up. V is P. It's P. Oh. It's P. It's P. Understand? In this case, V is P, is N, is N. The magnitude are the same. So, P over the area. Over the area. Bearing first. The area is this one. For bearing stress, this is the bearing surface. The bearing surface. Look at it.
How do they get the area?
How do you get what?
How do they get
Yeah, the diameter. Thin is the diameter. Yeah. So
Yes.
the diameter.
It's 10.
The diameter is 10 millimeter. The thickness is
So that's given this.
the thickness of the blade is 15 millimeter. So the diameter not this. The diameter is 10 times 15 millimeter square. Yes, sir. This is the area. Is 10. Is 15. Yes, sir. So P, we can P is 12 kilonewton. There are another law of stress, shear stress. A law of shear stress. Shear stress. A law of shear stress is P. The area is the cross section of the board. That's not. The shape of the cross section of the board is a theta. So it's the area is this one. So we can get P is this one. So it means if the plate for the plate, if P is more than 30 kilonewton, the plate will be broken. For the bolt, if P is more than 12 kilonewton, the bolt will be broken because of the shearing stress. Because of the bearing stress. if P is more than 18 kilonewton, is more than a local stress of pillar by shear stress.
So why is E equal to T by 2? Yeah.
It means it's difficult, this problem. Now look at this. Look at this. Look at this. It means for the plate, let is planet for the plate, it is the plate, is not. That's not P is here. That's not
Yes.
is P. This part may be lost. Yes or not?
Yeah.
Separated away by P.
Yeah.
So this is there is a way. In this way, give me. We be broken like this. We be broken like this. It will be broken like this, the plate. It's not like this way. So we have to judge this failure mode will be happen or not. Understand?
Yes.
Oh. So it's complicated. Yes. Is tension. It's a tension. Failure by plate is a failure of plate by shear.
Yes.
Understand? Yes or no? Failure by shear is this. In this case. This case. Yes or no? So, is the formula. If P is more than 18, it will be broken like this. For the bearing stress of the boat. So, P compare the above results. The notice the load for the connection depends on the boat shape. Therefore, P is 6.28 kilonewton.
Yeah, that's conclusion.
Ah.
Understanding conclusion. Why did they say that the largest equilibrium for the connection depends upon the boat shape?
What?
Why did they pick P?
What's in
Yeah, because it's the smallest.
Yeah,
Oh.
because it's the smallest one.
For
It means the bearing stress when the connection will be failure It is because of the bearing stress. In class problem, yeah, is the difficult. In class practice is time. There is no time. I give you an assignment. Homework. Time is over.
Sai, continua na sua
homework
Se você é o John,
is important. The diameter is 4 millimeter. The largest is 20 millimeter. Is 20 millimeter. The thickness is 5 millimeter.
Reason for the
Diameter.
P
4 millimeters is the length of the
P is 100 Newton. I ask you find the normal stress in the plate. Find the normal stress in the plate. The shear stress is shear stress important. Bearing stress better change shear. Bearing stress important. Understand? Here is the question. I ask you find the largest normal stress in the plate. Shear stress and the bearing stress in the board. This is the homework. Can you know how to solve it? Can you know how to solve it? That's all for today. Okay? Can you know how to solve it? Huh? Yeah. Where is the